So I'm going to do another example, and this one is about Atlanta commute times. We want to learn something about the average commute times in Atlanta from 2004, and we're going to find and interpret a 95% confidence interval. So one thing that I'm going to need to know when I get to StatKey is the kind of parameter that I'm trying to do inference about. So if I start here, I need to know, is it a single mean, a single proportion, difference in means, difference in proportions, etc. So I'm interested in the average commute time. I think that's going to be a single mean. And then this is one of the data sets that's built into StatKey, so I can use the drop-down menu here. I'm going to change it from Mustang price to Atlanta commute time. And now I can see my original sample right underneath my video here. And it looks like the mean commute time was 29 minutes, 29.11 minutes. I don't exactly know what that is in seconds, but around 29 minutes. And there were 500 samples, n equal 500 there. So I could take one bootstrap sample. It's going to be also of size 500, but it's going to maybe get some of those people with the really long commute times out beyond 150 minutes. It might sample some of those people many times or maybe not at all. And I'm going to click generate one sample, see what happens. So it looks like I got one person with a really long commute time, and then I got some of these other commute times maybe repeated more than once. The mean was really close to the original mean. It was basically the same, but the standard deviation was a little different. So I'm going to click generate one sample again. Okay, now I got a slightly different mean. This time my mean was 28.02 minutes. Click generate one sample again. 28.164, again and again. I'm trying to find one where we get a lot of those long commute times, and it pulls the mean up. That sort of does it, 29.756. Okay, I think I'm gonna try and just be lazy, and I'm gonna click generate 1,000 samples. So here is my bootstrap distribution. Now I've got 1,018 samples because I clicked the generate one sample button a bunch of times. I think I'm going to put a screenshot of this into my notes. Okay, so again, I've got my bootstrap sample, I've got my bootstrap statistic, and I've got my bootstrap distribution. And my distribution, let me move this up a little bit. My distribution is centered around that original sample statistic. 29.148 is pretty close to 29.11, and it would get closer and closer as we took more and more samples. And if I wanted to create a 95% confidence interval, I could do the statistic plus or minus 2 times the standard error. And in this case, my statistic is X bar. So I would find my observed X bar, that's the 29.11, plus or minus 2 times, then here's my standard error, 0.941. So that's 29.11 plus or minus 1.882, or 27.2-ish to basically 31 if I round. So that would be my 95% confidence interval. And I could interpret this confidence interval by saying I'm 95% confident that the true average commute time in Atlanta in 2004 was between 27.2 minutes and 31 minutes. So I'm pretty confident that it was right around 30 minutes. If I had a really wide interval, that would mean I'm not really confident. Maybe your commute was 10 minutes, maybe it was, 2 hours. But here, my confidence interval is pretty narrow. I'm pretty confident about that. So this is one way to make a confidence interval. It turns out you can also use StatKey. So just like we did with the normal distribution, we could click the two-tail button, And this would show us the middle 95% of the data, and then the numbers that are bounding that middle area. And it's very similar to the one that we found using the formula. It's a little bit more based on the simulation, but it gives you the same idea. And then I have two more examples. There's one about global warming. It's data from a survey of people in 2010. They were asked if there was solid evidence of global warming, and 1,328 of them answered yes. And then there's another version of that same data set, which is broken down by political party, the number of Democrats and Republicans who said yes. And then we're interested in knowing if those numbers are different. So I'd like you to try to figure these out on your own. I'm just going to give you a couple hints in StatKey to get you started. So one is, if you're doing the original one about global warming, you would go to StatKey, and you'd have to think about which of these bootstrap confidence interval links you want to click on. And it turns out for this one, you want a single proportion. And I don't think that global warming data is in the dropdown, so it's not one of the ones here, but you can click the Edit Data button, and you only need to put in two numbers. The count, that's the thing that you're interested in, and then the sample size, that's the total number of samples. So I'll let you try and figure it out from there. And it's a similar thing for the political party and opinion about global warming. You need to pick a different link on StatKey, but you also need to edit the data. And again, we'll talk about those during synchronous class.